All right, so these are degrees. This is the height. So how do we draw this? We'll draw a level plane, horizontal plane. This represents the sea. It says that a plane is flying, okay? So that means there's no connection to the ground, right? It's just a height. All right, so let me, okay. So we'll draw a plane. This is what I want to see from your, I want to see this in your assignment, okay, guys? I want you to draw a plane. All right, and we know the height of this plane is 265 meters. 265 meters above the ground, okay? And so we know that the pilot has a line of sight. So let's draw the line of sight. It's parallel to the sea, right? It's parallel to the sea level. Okay. And now we're going to look at the two boats. So the pilot looks down and he sees two boats on the sea. One boat here. And another boat here. Oh, let's put it a little further away. Okay, so these, oh my goodness. It must be going so fast that it's jumping along the sea. So let's make sure it connects to the water. There you go. It's pretty fast boats there. All right. So angle of depression. Let's draw a line down to the boat. Oh boy, didn't work. Try that again. This is when math gets cool because you're drawing stuff now. Then other angle of depression. There you go. So now, what are we looking for? They said they want to know the distance between the boats. So we're looking for D. But we have these other distances to care about, right? We have this distance to think about. We'll call this one X. And then we have this other distance to think about. This major one here. See how much distances we have to worry about in this problem? Okay, so now guys, I'm sharing this with you because you guys you made the effort to log on and it's not easy to do that. And so I'm helping you out with this part of the assignment. Let's just keep going. All right, so now let's look at this one here. Look at that angle. And then look at this one. Which one do you think is the 25 and which one is the 35? Is the first one the 25 or the second one? You still there? You guys still there?
What's the question, sir?
Which one would be the 25 degrees? The first one or the second one?
The first one.
The first one. Okay. Yep, it's not a trick question. All right, so this will be my 25. And the boat that's closer actually gets a bigger angle. Does that make sense? When something's much more further away from you, the angle of depression would be much smaller. The further it is, further down the road it is, your angle of depression is much, much smaller than if it's right below you. You know, you could look down at your feet and you could imagine that angle of depression. It's very big. It's almost 90 degrees. Isn't that correct? But if you look at something in the distance, your angle of depression will be a lot smaller. Okay, so let's keep going. We know something about parallel lines and transversal lines. We know that they form alternate angles. So let's see if we can find those alternate angles. Okay, so let's do that. Let's look at this 25 one. So I'm gonna try to show you, help you identify the alternate angle, how it works. So notice I highlighted that little angle there, and it corresponds with this angle here. It corresponds. It actually makes a Z shape. So pay attention to that Z shape. Once you have two parallel lines, right? The line of sight and the ground level or the sea level form parallel lines. Parallel lines are lines that never meet. They don't converge. They don't intersect at some point. They just keep going side by side continuously. Okay. So these parallel lines, once you cut those with a transversal line or like a diagonal line, you can form alternate angles. So I know what this angle is. Guys, what is this angle here? What's this angle going to be? Can anybody tell me what this angle will be?
The 35, sir.
It's corresponding with this one. See, it's alternate. So alternate angles are always equal.
Oh, okay, sir.
So it's 25. No problem. Okay. So alternate angles are always equal, and they have this kind of shape to them. So if you have a line, two parallel lines, so these, imagine this line never meets with this line, and you have an angle here, it will be the same as the angle here, alternate angles. So if this is A and this is B, then A equals B, and we'll give it the name so you don't forget. Alternate angles. Yeah. Okay, those are alternate angles. Okay, so now we'll do the same. We'll change the color. I think this blue is going to work. So what about this one here? Coming across here. I'm still at red. Okay, here. So see, doing the same thing again, but this one is dealing with the bigger angle, isn't it? And it corresponds with this angle down here. So what will this angle be?
35, sir.
35, that's correct. So there we go, 35. Okay, now, so basically we have two triangles. We have one, looks like this, with a 35. Right, it has 35 degrees to 65. Right, and then we have this other triangle, same height, but just a little bit, I guess, a little longer, and it has 25. But it's also 265. And what do they want? Well, for both of these, yes, our goal is to find this thing here. But to get there, we need to find this, we need to find the x, right? So let me show you what we need to find. We're looking for x here, and we're looking for y here. And the idea is, if I want to find d, d is going to actually be y minus x. Isn't that kind of cool? Let me just, does that make sense to you? I can find this whole length here. I can find this length here. And once I subtract this x out, what will we be left with? D, the value for d. And that's basically what we have to do.